So how do we solve problems using two variables? Well, you've done these before. Look at example 1. The sum of two numbers is 5. The larger number exceeds twice the smaller number by 14. Find the numbers is a question. We did these sort of questions before. We're using one variable. Now we're ready to use two variables to do these kind of questions because we know how to find the solution to systems of equations, correct? So let's then use two variables, okay? And it's actually not that hard. So go ahead and write it down. I'll give you time. So let's start with then, whenever you have more problems, we use 5-step plan. So first step, of course, you read the problem and look at what your unknowns are. So since you're going to use two variables, what are these two unknowns? Yeah. X and Y, and what do they represent, you think? Let X to be what? Let X to be the small number and let Y to be the larger number. Okay? And I believe that's what I did here. Very good. Now I highlighted the first sentence because many times people forget to use that first sentence. When you have two variables, how many equations would you need to solve? How many unique equations do you need? Yes? Yeah, you need two equations, right? If you have two variables, you need two equations. So, does anybody know what the equation for what our first equation might be? Yeah. X plus 5 equals to 5 because it says sum of the two numbers is 5, correct? And it says then, that's my first equation. There's my first equation. What would then my second equation be? Yeah. Y plus 14 equals to 2x. How many people agree? No one does? Oh, okay, there you go. So, correct. It is going to be y equals to, I wrote 2x plus 14, same thing, right? 14 plus 2x. And it says, it's because the larger number, which is y, exceeds, what does exceeds mean? Yeah, it's greater than what? Twice the small number by 14, right? So you multiply twice the small number and then add 14 to it. That's equal to the greater number. Yeah, question? Oh, that's a good question. Shouldn't this be y greater than or equal to 2x plus 14? No. Why not? No, it shouldn't be. Why not? Raise your hand. It sounds like it says the larger number exceeds the twice the small number by 14. So shouldn't we be using an inequality symbol here somewhere? Not really. Why? Why not? Can somebody explain? What does this second sentence mean? How come we don't need to use inequality symbol? Yeah.
Basically says that the number is 14 plus twice the small.
That's exactly what it's saying. It says the larger number, when they said it's, you could actually rewrite this as the larger number is twice twice the smaller number plus 14, or more, right? 14 more than twice the smaller number. It just says larger number is bigger. Of course, larger number is bigger. Well, how much bigger is it compared to the smaller number? Twice the smaller number by 14. So you multiply that by 2 and then add 14. That's what it's saying. Does that make sense? Okay, so we have two equations. Which method would you like to use? It's kind of nicely set up for substitution, isn't that right? Go ahead, everybody go ahead and solve. I'll wait for you. And help each other out. Okay, you could ask your group. All right, who thinks they know now how to write that third equation then using only one variable? Yes, Stefan?
X plus 2x plus 14 equals 5.
Exactly. And you use parentheses, right? And if you think back, isn't this what we did at the very beginning of the semester? When you have something like this is what we did. We just use one variable, right, to write this equation this way. Remember, let x to be, I don't know, small number, then the other number has to be 5 minus y or something. Didn't we do something like that? Do you guys remember? Anyway, let's move on. Then, how do we solve? Gather your x's together. What's the answer? Yeah, one person knows? Does anybody need more time? Okay. Yeah, Allie? Yeah, tell me the x equals to -4. I got -3. Oh, you said -3? I just heard you wrong. My bad. You're right. So x equals to -3. Therefore, y has to be then. We could either plug into the second equation or the first one. Isn't the first one easier? Right? What do you get, guys? Y is then 8. Easy enough? So we found the two numbers. So, of course, we got to check both equations. And the numbers are -3 and 8. Okay? So when you add them together, so how do we check this? When you add them together, do we get 5? Yes. And if we plug into that second equation, -3 and 8, look, if you plug in -3 here, what is 2 times -3? -6. What's -6 plus 14? 8, right? And any question? Are we good, guys? All right. Then let's try the second problem. A pet shop sold 23 puppies and kittens in 1 week. Does this mean they sold 23 puppies only? No. Okay. So it means they sold 23 puppies and kittens. So combine both of them together. They sold 9 more puppies than kittens. Okay. What do they sell more? Puppies or more kittens? Puppies. Okay. And the question is, how many of each did they sell? Go ahead. See if you can do this yourself. Well, actually, as a group, go ahead. I'll give you time. How about Eric? What are my 2 unknowns for this?
Puppies and kittens, X and Y. Like X is puppies and Y is kittens.
Yeah, I use P and K. Is that okay? So it's nice to use variables that kind of represents the unknowns. So you could use X and Y, that's fine. So what would be my first equation here? Yes? Good. Don't forget the very first sentence. Okay? We get P plus K equals to 23. What's then the other equation that we need? William? Look at the second sentence. P plus 9 equals to K. So that means if you were to add 9 to number of puppies that were sold, does that give you a number of kittens? Which do we sell more, puppies or kittens? Puppies. So do you think it should be P plus 9 equal to K or K plus 9 equals to P? Okay, how many people wrote down K plus P equals to 9 there? Okay? K plus 9, I mean, equals to P, right? P is equal to K plus 9, isn't that right? So, okay, good. Then, which method should we use to solve this equation? Again, it's nicely set up for class. Substitution. So somebody tell me our third equation that we get from here. William?
P plus 9 plus K.
Exactly. In place of P, by the way, when you substitute it in, should you use parentheses?
Yes.
Yeah. So then, do anybody need more time to solve, or are you already done? Yeah, Alvin, are you guys done? Yeah? What'd you get, Alvin? So here, we're solving for K, so don't you get K? 7 for kittens. How many people got 7? Okay, let's see. You're correct. If then you sold 7 kittens, guess how many puppies you sold? You sold 9 more than this, yeah? 16. That's correct. Thank you, Ryan. So there you are. So it makes sense then, if you look at the very first equation, it said total number of puppies and kittens sold were 23. And the difference between puppies and, we have more puppies, we have 9 more, right? Question? Okay, why do you think that is? So some of you got, one of you guys said that you got 9, what did you say? You got?
No, I got the same answers, but they just switched.
Yeah, why do you think they're switched?
Well, because I did 9. I did P plus 9.
Yeah, you did P plus 9 equals to K, is that correct?
No.
What do you have more, kittens or puppies? So do you see your mistakes now? So if you made a mistake on the second equation, if you wrote instead of k plus 9 equals to p, if you did k plus p equals to 9, p plus 9 equals to k, that will be wrong, right? Look at the question. If you wrote down, well, if you wrote p plus 9 equals to k, that means what? You have more puppies than kittens. Does that make sense? I mean, you have more kittens more than puppies, so be careful. It says we have more puppies, right? Not kittens, right? How many, right? Whatever number of kittens we have, you have to add 9 to make it equal to, right? So you could think of it as you have 9 less kittens than puppies. All right, may I move on to the third question. Here you are. And like I said, these are all the questions that you've seen before using one variable. Now we're just using two, okay? A bank teller has 112 $5 bills and $10 bills for a total of $720. How many of each does the teller have? Does this mean the teller has $112? No, what does 112 represent?
The number of bills.
Just number of bills. Doesn't matter if it's $5 or $10 bills, right? He has 112 of them. Some of them are $5 bills, some are 10, and now it totals to $720, right? Go ahead. See if you can do this one yourself. I'll give you time. So who thinks they know what the two unknowns are for this case? One person?
Oh my gosh.
That's it? No one knows what the unknowns are. Yeah, Aaron. Yeah, tell me both of them. Let,
5x plus 10y equals 720.
Oh, those are the tell me the unknowns. Let's declare our variables first.
Oh,
So let what?
oh, let x equal a number of $5 bills.
Good.
Then y equal a number of $10 bills.
Good. And we're so used to using x and y, but whenever you start using more than one variable, it's kind of nice to kind of name this variable with a variable that kind of represents what it means. So when you're doing the problem, you won't get confused. So it kind of makes sense to use f for $5 and t for $10, but you don't have to. You don't have to do that. Okay, good. If I did this, somebody give me one of the equations. Look at the very first sentence. Vlad, what do you think? My first sentence should be what? My first equation should be what? That's okay. You can give it to me as an x and y. Sure. If you add these together, because these represents number of bills. Whoops. It represents number of bills, so it makes sense when you add these together. You have 112 of them, right? Now, does that mean we have $112? No. Okay. Now, what's then our second equation? Yeah.
5x plus 10y equals 720.
Sure. I did 5 times 5. Yeah, it doesn't matter. So if I use f, it'd be 5 times f. See, $5 goes with f. 10 times t, because these, right, are how much they cost for each of these bills. And when you add them together, it's 720. Does that make sense? Does anybody need more time to solve? No? Okay. Let's see. Jamin, what'd you get when you solved this equation? How many $5 and $10 bills do we have?
We got 32 tens, but I didn't take up
Oh, you got 32 tens? Okay, so you got t equals to 32. Which method do you think is appropriate, guys, to solve for this? Yeah. You could use substitution, that's fine. You could use addition if you like. You can multiply the top equation by -5, right? I think I use substitution. Doesn't matter. Okay. So, oh, you divided the second one by 5. That's actually even better, because then you would get very good, very good. Excellent. So somebody noticed. Wait, I have a factor of 5 on the left and right side. So why not divide both sides by 5? And then you could add it, or you could use substitution. You're correct. So when you solve, you should have gotten. You said 32. Yes, very good. So there are $10 bills. There are 32 of them. And of course, if there are 32 of them, because there are 112, bills, there are $85 bills. Does that make sense? And of course, you could verify it by plugging it in, and it works out. Any question? So there, I checked both of these equations, and I got it. So you need to write it as a sentence, right? The teller has $85 bills and 32 $10 bills. Any question? All right. Go ahead and write this down. Example 4, Ken invested $5,000. Again, these are the kind of questions you've seen before. some at 6% and rest at 5%. His annual income from the investment is $280. How much is invested in 5%? Again, when we did this sort of problem last time, we used one variable. Now we could use two variables, and because we know how to solve systems, it's pretty straightforward. So, what are the two variables that we're going to be looking for? Are you still writing this down? Okay, let me give you time. Go ahead and write it down. Come up with the two unknowns, okay? Declare these two variables. Go ahead, everybody try. You could help each other out, that's fine too. Who could tell me what my unknowns are for this? Sarah A, what do you think? What are our unknowns here? Very good. X is how much you invested on 5%, how much he invested, and then? Exactly. And that's what I did too. Very good. Okay. Then, what is our first equation? Two people see it? 3, 4. Chris, what do you think? What's our first equation? Yeah, x plus y equals to 5,000. That's exactly right. Look at the first sentence, right? If you were to add up the amount of money he invested for each of these investments, right, 5% and 6% interest, it equals to 5,000. Now, then, what is our second equation? One person knows? Look at the second sentence. Two people. That's it? All right, go ahead, Eric.
Okay. 6 over 100s plus 5 over 100n equals 280.
That's correct. I wrote it as a decimal, but yes, you could have written this as a fraction.
I wrote it as a decimal. I just said
Oh, okay, good. Now, did anybody write 5 and 6 instead of 0.5, 0.05 and 0.06?
I did, but then I put
Oh, then you multiply both sides by 100? That's fine. So that's what I would have done, actually. After you notice that it's percentage, so you have to change it to a decimal. And then because I don't want to deal with decimals, I just multiply both sides by 100, right? And do we know how to solve these equations? Could we use addition method if we wanted to? Right? You can multiply the first equation by what?
5.
I will multiply by -5 so that it cancels out. Or you could use substitution method, whichever you like. Do you guys need more time to finish it up?
Yeah.
Okay, I'll give you some more time. Go ahead. So, when you then solve, I use substitution method. So I plug in x. So I solve for x. I said 5,000 minus y is equal to x. Is that okay? How many people got the answer? How about somebody that I didn't call today? Who haven't I called? How about Ryan? What'd you get?
Is it 3,000? You invested 3,000 and 5% and 2,006%.
No.
So he invested 3,000 for 6%, didn't he? So therefore, if he invested, because that's what y stands for, right? And we're looking for the x, aren't we? Because they want to know how much was invested in 5%. So you should have said $2,000 was invested at 5%. Any question? Do you see how I use the substitution method and solve? Yeah, question. Any question? How many got this right? Raise your hand. Let me see. Very good. Easy enough? Again, you could have done this with just using one variable, but using two variables kind of makes it a little bit simpler. I don't know. A little bit more organized. Okay. Yeah. Questions? We good? All right. Good.